Okay, so welcome. This presentation is also recorded, so you can also watch later. So I have designed this program as kind of a set of ideas that you can try later, or if give you some inspirations to try out some of the projects. So I will start with stating what is my agenda. So I'll first go with some of the guiding principles that you need to be aware when you are working with the machine learning related projects in Wikimedia. And second, I will go through a list of projects that currently we are using and something that you can use it for your personal purpose, just for fun, or using it for your various purpose. So I'll talk about machine translation, text to speech, speech to text, optical character recognition, and compute optimization so that you can try it in inexpensive systems like your laptops. And then I'll also briefly talk about large language models and some fun projects that you can play with the Wikimedia projects. And I'll also talk about some interesting data sets that might be interesting to you. All right. So let's go to some of the basic principles. I will not go to the details of all the principles, but I'll state only some of the few principles. So you can learn the full principles about the principles that are governing projects in the Wikimedia Foundation in this link. But in general, one of the basic thing is like it's about free and open source. So when you are working with some of the machine learning projects, please be aware that we are very serious about free and open source projects. So if your projects and the tools that you use while doing hacking, if it is free and open source, that aligns with our mission. Second, be aware that our language diversity. So as you know, Wikipedia is not just English, it's 300 plus languages. So if you are doing projects, that should be by keeping this in mind, that we are not just doing something for English. Think about whether it will work for other language, how it can affect other languages, okay? And we also need to make sure that this is a small piece of advice. It's one of the principles in Wikipedia stated. Wikipedia is not a laboratory. It's like Wikipedia is used huge in all the research purpose, but Wikipedians are actual people who are spending their free time in Wikipedia. So if you are experimenting, there are some guiding principles in Wikipedia, how you can experiment, because you need to respect people's time and efforts. So why I'm choosing this series of topics for the session, like if you listen carefully, it's all about languages, right? So in the last developer survey, we have seen that most of the developers, for them, English is not the primary language. So this is according to the 2023 developer satisfaction survey. They said people are not primarily English speaking. They might know English, but that's not their primary language. So that means developers are hugely multilingual. They are aware of non-English languages. So the projects that are relevant to their language might be relevant. So that's why I chose this kind of series of projects that might be interesting for your language. All right, so let's start with the machine translation. So in this set of ideas, I will just give some inspiration for you to start some projects, some food for thought, that kind of ideas. So if you know, machine translation is the idea of translating content from one language to another language. So I just wanted to tell you that there is a self-hosted machine translation service currently available in Wikipedia that anybody can try. It's free of cost API that you can play with as you like for any fun projects. This was recently announced, and you can just go to translate.wmcloud.org and play with this interface. You can not only translate plain text, you can also translate HTML, JSON, Markdown, SVG, web pages, text, all of these kind of structured documents, you can just translate with this interface. Along with the interface, there is also JSON, there is an API, so you can build some cool ideas. Some projects that just use this API, do the translation. What you can use for this, any project ideas, that's up to you, but machine translation API is available. So if you look at some of the fun projects, people will say that, okay, use Google API, etc. But this is free API you can use today, right now, in your laptop. So try to build some cool applications using this machine translation API. And secondly, you can I'm just giving some ideas that you can try it out. So it's like a browser plugin, for example. These are just examples. These are not, I'm saying that you should build this one. I'm just throwing some ideas that will inspire you or think about some related ideas or some other ideas. So something like you are going to a talk page, it's written in some language you don't know, select that one and just quickly translate. For that you need an API, right? Machine translation API. And you have write it in right inside our Wikimedia API system. Secondly, something like section translations like in Wikivoyage. Wikivoyage is available in a small set of languages. Write some gadget or something like a translate to my language. There is an also API to detect the language automatically. So given any text, it will detect the language automatically. So sometimes you don't need to select what is the source language. You only need to choose the target language. Maybe you can choose it from the browser. So just some ideas. Thirdly, like some crazy ideas, like if you club with speech recognition, machine translation, and text to speech back to back and compose together, will you get speech to speech translation? I don't know, just try it, because I will also talk about speech recognition and text to speech. I will also talk about how to get all these services without relying on proprietary services, but just within your laptop. I mean, not even in the cloud, within your laptop. Okay, so this is another idea that you can try it out. So if you want to note down the URL, it's a translate.wmcloud.org. Just wanted to note that it's a test instance. Sorry. Here, let me show you. So this is that interface. It's a test instance. If you scroll down a bit, you will see API spec and source code. So you can get all the details related to how to try it out. Okay. So I'm not going to do any demo here because to save time, because I have so many other content to present. But just note down that translate.wmcloud.org is this one. But wanted to note down that this is not a production instance that will scale up to all your needs. We set it up like a testing demo instance. We have another instance of the same thing that is in production that is actually serving our content translation project, and that is more powerful and running in an actual hardware. So this is just a virtual instance just for the demo purpose. But don't worry about this uptime and etc., because it can run in your laptop. You can just download the source code, or there is a pre-built Docker container. Just go to this URL. All these links and URLs are linked in the Fabricator ticket. So you will get all the links, and even if you need not note down all these things, you can get it from the Fabricator ticket. So you get a Docker image, Docker pull, Docker run, you get a fully running machine translation system right inside your laptop. No GPUs are required. If you want to run it without without Docker, you can just clone this one and follow the README instructions, and you will get a machine translation system right inside your laptop, suitable for any kinds of experiments. And the good thing is that this has more language cover than any other machine translation system that you can access with the paid APIs and all. So if you access Google Translate or any other system, you will not get this kind of language coverage. Currently, we have a language coverage with this system. Like if you run it in your laptop, you are getting a machine translation system that can support 198 unique languages, maybe one of the biggest machine translation system. And when you say 198, it's not just English to Spanish or English to Catalan, not that kind of thing, between any of these languages. So any language to any other language, you can get machine translation. And that will constitute, like currently we measured, it's like 35,924 language pairs. Between these pairs, you can translate. So what you can do with this API, it's up to you. Just think about some ideas how you can use this kind of powerful system right inside from your laptop. Another set of ideas that I will put it for you is, because this is a resource very optimized for resources. If you put this in host it in your personal web server, if you have, put it in your university, make it open for all the students in the university and staff, and save money because you can translate without paying API cost. The quality is, from our feedback, sometimes it's much better than Google Translate, because we use state-of-the-art language models for many of the languages. And even from my own personal experience, for the languages I speak, it's much better than Google, way better than Google Translate and other common systems, because of the recent advances in the machine learning technology related to machine translation. So these are some ideas. So if you open it up, something like a available machine translation service for your local community, local university, Wikipedia chapter, you are helping the free knowledge mission by making these knowledge curation tools universally accessible for more and more people. And this will not take like purchasing an extra hardware or extra machine and all. Maybe you can run it in the same server that you are running in for your website. All right. So this will also help us to, share the computing required, and maybe like Wikipedians can use this tool for researching content, for writing Wikipedia articles. So that's another idea. And if you are interested in this one, I had linked a document explaining how to do this, how to host this in a separate domain. I had linked that document in the Fabricator ticket. All right. So another thing is like you might be speaking a language other than English. So another idea is go and test this, give us feedback how it is. And this is free and open source, so there are various ideas we can improve it. So that's another advantage of having our own machine translation system. Then another thing is like this idea of 198 languages, it was possible because we collected various open source neural machine translation engine models and collected and provided as a single API host. But there might be languages, we have 320 languages. So 198 is low, like we have more languages to cover. So if you know some machine translation models for your language that is good for your language, let us know. We might be able to integrate, and we might be able to help more people with that service, and we can enhance this from 198 to 320. That's our ultimate aim, like supporting machine translation for all the languages. All right. So another set of ideas. I showed you that it's not just a plain text translation. It can translate HTML content, any arbitrary HTML, not limited to Wikipedia HTML, any arbitrary HTML, any web pages, or any of this one. It can adapt. It will know about the HTML structure. It will retain the HTML structure. It will only translate the required plain text part. It will retain links across languages. So the markup transfer is also available in the service, so you can use it for any kind of HTML. It is also aware of translating JSON documents. Where you can use, it's up to you. It can translate between JSON to another JSON file in different language, and it can also translate between markdown documents. Markdown documents. It can translate. It's aware of the structure. SVG. SVG is used a lot in Wikipedia for illustrations, science illustrations, and medical illustrations, and all. So you can translate SVG from one SVG to another. Let me just quickly show you that. Just a demo here. So just a demo SVG, translate from English to Spanish. You get SVG translation. So this is just a funny example, but think of like a solar system, the planetary system, or any complex SVGs with a lot of text and illustrations. You get a SVG that can be suitable for your Wikipedia. Just one SVG you can use everywhere by just translating text. While I'm showing this demo, I can also show like this markdown sample. So you can see that the links are also adapted inside markdown. I was talking about HTML, so this is an example. Even if it is translated, if the link text is completely changed, it will retain the links. Formatting, any kind of formatting, links or any arbitrary, all HTML structure is supported. JSON, for example, structured documents like this, you translate, the values that are strings will be translated to your target language to 198 languages. Let's go back. So some ideas. How about adding more support for more formats, like movie subtitles? One example. Word documents, open document format for documents like presentations or such documents. So all those things are up to you, like which format that you can try to see maybe PDF documents, PDF to PDF translation. So if you look at some of the, for example, Google Translate right now does not support SVG translation. It cannot translate plain text. So all these things we already have. So try to add more formats into this one. How to add those formats? Look at the documentation available in the source code of the repository. It's actually very simple way to, you need a parser, then extract the string to translate it, apply back to the same parser and generate the document again. That's a basic idea. So you can try supporting more and more formats into this one. Let's go to another topic, optical character recognition. You know where it is used, right? For digitizing documents, for Wikisource. Wikisource, yes. But not necessarily Wikisource. Sometimes you need to add content to Wikipedia by looking at various documents, and you may need to digitize those PDF or images or all those documents. By the way, in the previous session, you can also try for like a JPG to JPG translation by using optical character recognition. That's another idea. So currently, we use one of the most popular optical character recognition system called Tesseract for the Wikisource. We also use Google API and all, but Tesseract is also used. Tesseract is the open source engine here. So interestingly, you can run OCR. If you are not aware, you can run OCR within your laptop. So all the ideas that I'm explaining in this whole 1 hour session, everything is about running it in your local computer. Okay, so I'm not talking about any ideas that you need to get some paid APIs and also. Everything I'm talking about how to get this running. So this is an example. So the same slide, I'm doing OCR, I'm getting the OCR content out of this one. This one supports 148 languages. So right inside your laptop. How to get this up and running? I have provided the links how to get it running, about the documentation. I'm not going to the details of that, how to set up. Just like machine translation, try and see whether it will work in your language, because that's the most important thing. Secondly, try to build application using OCR. Like I said, PDF to PDF translation or JPEG to JPEG translation. Plug it through OCR to machine translation. Try and see. Annotated PDF documents, try and see whether it will work. So those are some ideas. It's up to you. Think about some ideas. There is also another optical character recognition system called transcribers used in Wikisource recently. It's specialized for historic document transcription, especially when the text is written long time back, sometimes using handwritten text or like a palm leaves. This is good at transcribing that from those kinds of very old, like decade or century old documents for certain languages. This software is not completely open source, it's kind of an open core thing. So the core source code for the transcribe is open, but it's very difficult to run it in your local computer. But at the same time, there is a documentation and a system that you can try it out. It's, if you go to ocr.wmcloud.org, you can try whether it will support your language and all. And there is also a documentation recently prepared by Wikisource team to see how to train the system for your language, to recognize this system. And that documentation is available here in this link. This is also linked in the Fabricator ticket. If you need some help with this one, Sam Wilson will be able to help. He's around here, I think. So contact Sam Wilson and he will be able to help. Yeah. All right. So that's about expanding content in your Wikisource or such documents by OCRing historic documents. Let's move to speech. So recently there was an experimental extension called Phonos that is to transcribe speech, especially when it is written using IPA. IPA to speech. So if you go to most of the Wikipedia articles, there's a speech icon and there is an IPA representation. So, but IPA nobody can read, but if you click, it will go to another page and it will have an audio. But this is to inline speech, text-to-speech conversion. So it's not limited to IPA. The original idea is to support general text-to-speech capability. But that's in the early stages. Do you know what is the roadblock with this one? We need a text-to-speech system that can scale to so many languages. And it should be free and open source. That's a problem here. But fortunately, recent advancement shows that we can have such open source TTS solutions. One example is a TTS engine called Koki AI, that's free and open source license. You can try it out. Actually, that had a lot of limitation about how to supporting languages. But recently, Meta, Facebook announced this project called MMS, Massively Multilingual Speech System, supporting more than 4,000 spoken languages. That includes dialects and all of those things. And it's a publicly available data set. And it's based on Facebook's on machine learning algorithm. And these models are available for so many languages. But I was trying whether we can get that running on our local laptops. And it's possible. So here is a demo. I had linked about this application. If you go to tts.wmcloud.org, you can try it right now. And let me show you that right now. Okay. So one example, if you go to tts.wmcloud.org, you don't need to tell the language because, like I mentioned, we already have the capacity to detect the language of the text. So if you just run it.
Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives.
See, yeah, it's actually good quality. So go to here, write your language and listen, and whether it will work for your language. In fact, it should support because like I said, it's supporting a lot of languages. So go to tts.wmcloud.org. Like I said, it's a test instance. So just like machine translation, all right. Just like a machine translation, you can get the repo. It's a link is given in the fabricator ticket. Clone it, run it in your laptop. It will run in CPUs. No GPUs required, and it will not take much time to transcribe text to speech. So try it, run it locally, and maybe if you find it interesting, host it in your university or in your personal service and make these kind of services more accessible to more people. So recent advancements of machine learning means it's more meaningful if it is accessible and available to more and more languages and thereby to more and more people. So that's the idea that I'm trying to tell with all these ideas. So try it out whether it will support your language or not. Let's go to speech recognition, automatic speech recognition. So there is an MIT licensed speech recognition system called Whisper, released by OpenAI. But if you look at the OpenAI, don't confuse that. This is MIT licensed, actually fully licensed or MIT licensed model speech recognition system. And people have been fine-tuning this for various languages. The actual Whisper is not that good for like non-English and many other languages, but people were, since this is MIT license, people were fine-tuning to your languages, and it's actually possible to fine-tune. There are a lot of documentation how to fine-tune it, and to try this one, there is also a project called Whisper CPP. I do not have a running instance for that one, but there is a Whisper CPP that's like a inference optimization, like optimizing that to run it in your laptops without GPUs, on just CPUs. With your local laptop, it should be able to run it, and you can do speech recognition. So try it out, see if you can get it running. If your language is not supported, try to add a new language. Now, I talked a lot about like this inference optimization. Why? Because as you know, most of the machine learning projects these days require a lot of computing capacity, mostly GPUs, hardware acceleration. And your personal development machines like your local laptops mostly does not have that capacity, and people are in the hurry to see where to get that computing capacity. There are a lot of ways people are trying to see how to get GPUs, how to get NVIDIA, all those drivers. And also note that these drivers may not be open source. So like I said, the first principle I mentioned in the beginning of this presentation, we are very serious about free and open source solutions. So GPU drivers are not open, and because of that, within the Wikimedia Foundation, we do not run those proprietary drivers for our acceleration. So we do not have any of these GPUs, NVIDIA GPUs currently in our infrastructure. If you want to read about the restrictions and how we can overcome these kind of things, go to this link. It's a diff blog post. But I mentioned that we were running this machine translation in our CPUs. This was possible because we optimized all these neural machine translation models into a inference optimization model. We converted all the models so that without losing the quality, it should be able to run it in your CPUs without GPUs. So all those optimized models are actually that powers the machine translation system that I mentioned earlier. So the technology behind this optimization, there are multiple inference optimization libraries. One is CTranslate2. There is another called ONNX, ONNX.ai. If you go that, you will find it. There are several other, like for large language models, recently there was like Llama CPP and all those optimization libraries are there. But this might be like, even if you have GPUs, just imagine that you have a lot of money and you don't worry about free and open source and if you just use GPUs. That's still a problem, right? It requires a lot of energy, right? By using a lot of energy and doing that, it's not good. In fact, if you can optimize, if you can run it on CPU, what is the incentive of running it on GPUs? Why you need to spend money? Why you need to spend energy? So please be aware of this optimization. Please be mindful about the energy usage for your machine learning models. Make sure that it's compute optimized, right? Okay, let's briefly talk about large language models. So first, I don't want to go to the implications of large language models because there was a lot of discussion recently. I linked 3 articles that I find very informative about using large language models and how it applies to Wikipedia. So I shared 3 links related to that one. So please read it to get an idea about how it intersect with the Wikipedia and all those things. I'll not go to the details, but please, I have given 3 links and it's also available in the fabricated tickets. But if you are not introduced into large language models and technology, I also shared 3 another links where you can go and study it, learn it in a very simple terms. So all these 3 links are also available in the fabricated tickets. So you can go and learn how it is working. The general technology, and also the last link is about a paper that explains most of the applications and with examples and a lot of information where and all we can use large language models and its implications, ethical consideration and all of those things. So it's like a recommended reading. There are so many links and resources these days, but this is my curated list for just to start. All right. Another thing about LLM is like you might be already know, to experiment, you need to use an API or you need to find a way to run it in your development system that will require GPUs, or you need to do compute optimization so that it will run in your laptops. So at present, we do not have any kind of that kind of service that you can use from WMF to use LLM. But we are doing a lot of experiments. We are watching this progress on LLM field very closely. So recently, we did an experiment with plugging this, creating a plugin, ChatGPT plugin. You might be already heard about that one. There is a blog post about explaining how this is working and the purpose of experiments. It's integrated with the ChatGPT. You can query Wikipedia and answer this one. So some ideas. It's very early stage how we can use LLMs. So some ideas I want to throw it, like if you're interested in hacking with the LLM, some ideas to try it out. Natural language question answering. So if you look at the Wikipedia search nowadays, it's mostly keyword-based search. You need to type the keyword. But if you want to write a natural language question and get an answer out of it, that's maybe depending on the question, the answer may not be correct, right? So this is one of the applications that everybody is talking, like even the ChatGPT is like you can write some questions in a natural sentence and you will get answer. There are some experiments how to use this one, and one of the major technology how it will work natural language question based on a set of documents in this context based on Wikipedia how to do natural language question answering. The basic technology for that is called retrieval augmented generation. So that is like, first of all, you get you have a question, and that question will be compared with the Wikipedia. It's not a plain text comparison. Wikipedia content will be converted into a vector embedding. Your question will be also converted to a vector embedding, and these two vectors will be compared for a distance, actually cosine similarity, but basically a distance. And then you will extract content in Wikipedia that are close to your questions, that can answer your question. Then based on the some of the sorting, you need to sort all this context, and the topmost thing, you can optionally feed into a large language model and ask large language model to articulate an answer to you. So that's the basic idea about RAG, or retrieval augmented generation. Retrieval is the vector distance calculation. Generation is the language model using to articulate the answer. Be aware that even when you ask an art to articulate with a given context, it's not free from hallucination. It will make up stuff. There is no guarantee that it will not make up stuff. So it will make up stuff. So, so I wanted to show some demo of that one, just to give an idea that whether it will run it in your laptops. All right. So some examples. So this one uses the RAG. Just to give an idea, okay, this is not anything like a foundation project or anything. Some examples that you can play with about an RAG. So I'm asking a question like this, to a type of region, and you can see that the LLM is generating the answer. It's streaming the answer there. The first step was retrieving all the Wikipedia articles and context inside Wikipedia that might answer your question. The top one is an articulation by an LLM based on the topmost retrieved section. So you got that one from this one, right? And it's a cached, that's why it's fast enough to generate this one. But if you ask a new question, you will see that all the cores in your CPU all go into 100%, and you cannot do anything in your laptop. So that's why I'm using this cached version. Otherwise, I'll need to stop the presentation, reboot the laptop, and all. So this is one example. But even just imagine that that fancy part is removed. Okay, that's the LLM parts. If you remove that part, I think still, if you do a natural language question and retrieve relevant parts of the Wikipedia article, that itself is useful, I would argue, right? Because that cross the challenges of like a keyword-based question answering into a natural language question answering. And we are not making up any stuff. We are just presenting what is present already in Wikipedia and just presenting it. So the retrieval, inside the retrieval augmented generation, retrieval itself may be useful, and for that you don't need any large language model. For retrieval, actually you need a tokenizer, actually, I mean, to convert all the text into vectors, you need some transformer-based model that can be easily done, and it's CPU optimized, because you can see that if I ask something, it's actually quite fast to retrieve that one. So that's very fast. And it's called vector stores, if you want to know about the details. But if you want to know about this software, this particular software, the link to that source code is already present in the fabricator ticket. You can go and run it there. Another idea that might be interesting to you. Okay. All right. Wikidata knowledge graph related ideas. So this is just a very early ideas. So sometimes an article is present only in one language, but for an article existing, most of the time there is a Wikidata entry and there are properties and levels, if you are aware of the Wikidata things. So with all these properties, there were some experiments in 2015 by some of the Wikipedians to see whether we can create a placeholder articles by extracting the properties and use some template. It was called a resonator by Magnus Mansk, by extracting some of these good properties, like there are a lot of properties, but some of the properties and values, do some templating, create some sentences out of it, and so that's like generating a placeholder for that article. And since Wikidata is like language independent. If you have a template string for those languages, you will get it. But one problem was that it was like one template for all kinds of things, and every article will look like same, and it is not fluent, it's not eloquent, it will be like robotic, and it has the limitation that if you do not have a template string for corresponding type of items that we are talking about, it will not work. So you can have for person and per place, but what if you use a large language model like this, you extract these kinds of property values, and use the articulation power of large language model to rewrite this thing into a natural language sentence. That's just a very basic idea. So this is to extract and rewrite. But this is also not free from hallucination. No matter how you fine-tune the prompts, like I'm talking this from my personal experience. I tried with various prompts, various LLMs to see if it can be constrained completely on the given data and not make up any new ideas. But you can see that here. Yes, which means that it is warm and humid throughout the year. Those are things that is coming from the LLM. We don't want that. We want to base completely on this one. And when I was trying, it was making up all these adjectives and explanations and all those things that is not present this one. That may be inaccurate, even if you can just generate all those things. So this is some ideas, but I'm not completely fan of this one. Like, actually, I'm not fan of putting anything that is produced from LLM and claiming that is from Wikipedia. That's not Wikipedia. But for your personal experiments, just throwing some ideas where you can be creative. I think mostly, according to me, large language models are mostly about creativity and not about knowledge, lookup, and everything. Use it for some creative problems and be aware of the limitations. I will go to data sets because data sets are the core of any machine learning. Like, it's the first part, and the second part is the software that use this data set and train it. So we were releasing, actually Wikipedia is already used in so many places. Large language models use Wikipedia as the data set, training data, but we were also releasing some data sets that are maybe useful for various purposes. And there is a ticket. If you go to that ticket, you will see various data sets we already released. And there is also a Hugging Face account, profile, recently created account for Wikimedia. If you go there, you will see interesting data sets that you can use it for various purposes. All right, some examples for such data sets that you can use it. Like, we extracted about 1 billion sentences from all the 320 languages by segmenting all the content into sentences, and that's published. So you have largest sentence collection. I think there is no other data set with this many languages and with the sentence segmented. And where it can be used, it's already used in an application that's already hosted in Wikimedia for identifying languages. Given a sentence, tell me the language. So that's a classification problem. And if you have the sentences and which language it is, it's a classification problem. And we trained it using a model called a fast text system. And we already deployed it. So that will tell you which languages. And I showed you already two examples where it is used, right? In the machine translation, you give a text. You need not tell which language it is. It will detect. And text to speech, you give text, it will detect the source text. So that's one thing. And then there is an experiment to create a data set of SPARQL queries and corresponding to a natural language question. Similarly, SQL. And then there are some examples of about data sets related to comments, images, captions, and all. So these are all some of the early data sets we released. If you go to the Fabricator link, I mentioned earlier, but this is also present in the Fabricator ticket for this session. So you can get all these data sets if you are interested in like using this data set and training some models and using for some various purposes. So that's all I have to demo and give some ideas. It's not limited to this one, but I hope this gave you some ideas about how to use machine learning for the benefits of free knowledge. I hope you enjoy it. Thank you. I think we have 5 more minutes, right?
What do you do with feedback? Is there anything that takes feedback in and tries to retrain the system or something like this?
Specific to any
Particularly to the Mint system.
Yeah, so there are a lot of feedback we are getting from community, and most of this feedback are about post-processing content. So something like you translate from one language to another language, and people are complaining that all the numbers are coming as English because their number system is using different numbering system. So like Arabic number system, Indian Hindi numeric system. This we got all this feedback earlier also. We communicated that to Google. They said they cannot do that because it's like a black box. But here we can do that one because inside the Mint we built a post-processing system on top of the machine translation, and we are accepting all the community feedback. Spaces after some conventions about the language, like how many spaces should be used after a period, and all those fixes. And then formal language, like some words are not at all preferred, some commonly found spelling mistakes. So all those post-processing steps we can incorporate. We are actually incorporating it. Punctuation-related issues, and all those issues we are trying to do. Like sometimes the full stop is not according to the language, but it's just a period. So those things we are doing as post-processing step. So that kind of feedback. The second feedback we are getting is about grammatical mistakes. These feedback, since we worked closely with these researchers who built this natural language, machine translation models, we are passing to them, and they are saying that they will be able to fine-tune it, their training data, like some filtering and curation of that training data according to the feedback, and make it version 2s and version 3s that we can bring it back. So this is just being open source will not help. You also need to collaborate with the researchers who produce it, communicate this feedback. We hope that it will work because we have a working relation with those neural machine translation models. Yes. 1 second. Okay, you can go ahead. Lydia.
Should we have a running transcribus system? And I recently read that they support newer versions linking to Wikipedia IDs. Do you know if the version we have supports that already?
I do not know the details. Sam Wilson might be knowing. Yes.
I was looking at the datasets on Hugging Face.
Okay.
In particular, the W18 dataset, which is released under a Creative Commons Attribution Share Alike license, but contains a lot of images from Wikimedia Commons. And I was wondering how and if the authors of the images are attributed as required by the license.
Okay, that's something that I cannot answer. I only know about the data sets. I think if you go to the fabricator ticket, you will find the owner of that data set, and you might be able to contact that person.
Okay, because this whole AI thing may be a problem with attribution.
Okay, sure, I understand. I think in that fabricator ticket itself, you can ask this question. Yes.
Are you doing a session tomorrow on machine learning at all?
Yes.
Yes. Different than this or same as this?
Different than this one. So yeah, there is a session tomorrow where I'll be talking about machine translation systems that are in production and used in bigger projects in Wikimedia already. So I'll talk about like where we are using machine translation in production. All of these ideas, these are not like used in production. These are like things that we are experimenting. You can also experimenting. Okay.
So tomorrow is called the state of machine learning in Wikimedia projects?
Yes, in the Wikimedia projects. The systems that are in production from 2015 that uses machine translation.
This is different because this is a bigger overall talk?
Yeah.
Okay.
That one is very oriented on the production systems and communities.
Because in the chat, people thought that this talk you're giving now was the one you're doing tomorrow.
No, no.
Tomorrow's a different one.
Tomorrow is different one. This is just inspiration and ideas, crazy ideas.
Great.
Tomorrow's is serious talk.
Thank you. I'll explain it to the folks in the chat. Thank you.
All right, thank you. Thank you for coming. If you need some help on these things or talk to you about any specific ideas, just catch me, I'll be around.